Introducing the Electron E1, world's most energy-efficient processor. The computing world just witnessed a seismic shift, and it's not from another incremental chip upgrade. Efficient Computer has unveiled the Electron E1, a processor that boldly claims to be the world's most energy-efficient general-purpose chip. But here's where it gets controversial. This isn't just another tweak to existing designs. It throws out the 80-year-old von Neumann architecture entirely. Could this mark the beginning of the end for how we've built computers since the 1940s? Let's dig in. I spoke with Brandon Lucia, CEO of Efficient Computer, to understand what makes the Electron E1 revolutionary. The chip's secret sauce? A radical spatial data flow architecture called the Fabric. Unlike traditional CPUs that waste energy constantly fetching instructions and shuffling data, the Fabric maps computations across a grid of tiny interconnected processors. Each one activates only when needed, slashing energy waste. Lucia claims this design achieves up to 1 trillion operations per second per watt, the staggering 10x to 100x improvement over today's low-power chips. But here's the kicker. Benchmarks show the E1 uses 350x less energy for the same tasks as conventional processors. How? Lucia breaks it down. When you tell a CPU to add 2 numbers, 95% of its energy isn't spent on the math. It's wasted fetching instructions and moving data. Our Fabric skips that overhead entirely. Let's address the elephant in the room. Does this efficiency come at the cost of flexibility? Surprisingly, no. The E1 runs standard C code, compiled into data flow graphs that the Fabric executes deterministically. Developers can even simulate programs on a web-based playground, watching instructions ripple across the grid like dominoes. Hardware deep dive. Spoiler, it's packed. The E1 isn't just clever software. Its specs are eye-popping. 4 mg of non-volatile MRAM retains data without power. 3 mg of Serum plus 128 kilobyte cache. 72 GPIO pins. And industrial-grade durability. Minus 40 degrees Celsius to 125 degrees Celsius. 2 modes, 6 GOPS at 25 MHz, SIP power, or 24 GOPS at 100 MHz, high performance. And here's the part most people miss. The E1's RISC core can shut down entirely while the Fabric keeps crunching data. Imagine a smart sensor that runs AI inferences for months on a coin cell. This chip aims to make that routine. But wait, can developers actually use this? Efficient's answer is a resounding yes. Their effcc compiler, built on LLVM MIR, lets developers write standard C code and compile it for the Fabric with minimal changes. Put your IDE to our compiler and boom, it just works, Lucia says. Even VS Code and CMake are supported. The controversy no one's talking about. Critics might ask, are these efficiency claims too good to be true? After all, benchmarks are from internal tests. And while the Fabric's spatial design is brilliant for predictable workloads, what about chaotic branch-heavy code? Lucia admits the E1 shines brightest in embedded AI, think sensor fusion or real-time control systems, but insists scalability is next. The upcoming Photon P1 will target edge servers and even data centers. The bigger picture. This isn't just about saving battery life. The E1 challenges a fundamental assumption. that general-purpose computing must be energy-hungry. If Efficient delivers, industries from aerospace to IoT could rethink how they design everything. Now over to you. Do you think spatial architectures like the Fabric will dethrone von Neumann designs? Or is this a niche solution for embedded systems? Let's debate in the comments. Is Efficient Computer's claim revolutionary or just marketing hype? Efficient Computer redefines energy-efficient computing with Electron E1 processor. Efficient Computing redefined. Electron E1 processor breaks new ground in energy efficiency. In a major milestone for the company, Efficient Computer has announced the release of its Electron E1 processor, now available for hands-on developer use. This marks the first standalone hardware release from the company, which is known for building the world's most energy-efficient general-purpose processors. With the Electron E1, developers can now build intelligent applications that were previously too power or compute-constrained to deploy at scale. The processor boasts industry-leading energy efficiency and general-purpose programmability, enabling transformative advances in edge, embedded, and AI product applications. But here's where it gets even more exciting. Efficient is also making its effcc compiler available for download for the first time. Previously only accessible via the compiler playground, the FCC compiler can now be integrated into developers' existing toolchains to compile and deploy code to the E1 hardware. This brings both the chip and software together for the first time outside of Efficient's internal sandbox. The Electron E1 processor and FCC compiler are built from the ground up to deliver radically better energy efficiency for general-purpose computing applications, said Brandon Lucia, CEO of Efficient Computer. Our spatial data flow design means that developers no longer have to choose between efficiency and generality. With this release, we're enabling the next generation of energy-constrained computing applications and devices. Unlike traditional von Neumann processors that consume excessive energy shuttling data between memory and compute cores, the Electron E1 processor is built on Efficient's Fabric architecture, a spatial data flow architecture that executes general-purpose code, eliminating the need for costly step-by-step computation. This approach yields up to 100x energy efficiency improvements over traditional low-power CPUs, enabling intelligent applications at the edge with years-long lifespans in environments where power and maintenance are limited. Efficient is now partnering with engineering teams ready to build with its latest chip and software, offering the Electron E1 processor, the FCC compiler, and hands-on engineering support, including collaborative optimization, code tuning, and architecture guidance from Efficient's team. As Brandon Lucia said, the Electron E1 processor is built from the ground up to deliver radically better energy efficiency for general-purpose computing applications. In strong knowledge and enthusiasm, the company is the RSC dedicated to the engineering, redefined, and innovations in high-vis teams of engineering developers and designers in applied quality computing collections. And here's the part that sparks some controversy. With the Electron E1 processor delivering radically better energy efficiency for general-purpose computing applications, will this technology disrupt the industry, or will it change the game? Ultimately, the Electron E1 processor is a moment captured in the history books. Let us know in the comments. What do you think about this groundbreaking technology? Do you believe it has the potential to revolutionize the industry?